Thank you for joining us for today's presentation entitled Optimization of Wastewater Treatment Plants. And please allow me to introduce today's presenter. Today's presenter is Mr. Jan Kretschek. Jan has over 20 years in the use of urban water modeling and technology and has played a significant role in the development and application of DHI's leading environmental modeling software and decision support systems. As a global sales executive and regional director for Central and Eastern Europe, he's a strong advocate for the effective implementation of integrated water and environmental management practices. And now I hand it over to you, Jan.
Thank you, Barbara, for a very nice introduction, and welcome everybody to the webinar that should be about and will be about optimization of wastewater treatment plants today. I would like to share with you the DHI view on how it could be done, a bit inside of technologies that we provide to our partners and customers. Before I jump straight to the topic, I like to say a few words about DHI for those who doesn't know us. DHI is the company that it's on the market more than 50 years. So it's actually twice as much I'm working for DHI. And actually this year we celebrated 56 year of our 56 years of our anniversary. And from the very beginning, we are acting as a technology developer, technology transfer company. We started back in the 90s or even earlier 70s with the first hardware informatics and normal modeling of 1D and 2D engines for rivers and oceans. And over the time, we grow to the truly global company, solving the challenges in all the water environments, from rivers to sea, from cities to oceans, industrial, and so forth. So this is what we are doing today. We are independent, private, non-for-profit organization with the headquarters in Denmark and globally present with more than 30 offices around the world in all continents, most of the continents. And that is why we are able to bring the technologies based on our dedicated research and also consulting work. The challenge today, and as I mentioned at the beginning, this webinar is about optimization of wastewater treatment plants. And when we look to this challenge, we can see it from different perspectives. One could be the global perspective, speaking the world, how this is working these days, like sustainable development goes. Some of you probably are familiar that clean water and sanitation is number 6 sustainable development goals by UN. And cities where 3.5 billion people lives today, and there is a forecast of 5 billion people in 2030, is another sustainable goal that we have to somehow, as a society, achieve. And all of these people, they need to drink water, and this water should be somehow treated. And this water should be somehow treated, when I say somehow, it has to be treated in a way that we do not harm the environment, because the water has to be reused. And then not only harm the environment, but we also make it as economically, sustainable as possible. Speaking the other way around, of course, we like to treat the water as cheap as possible. And that could be the global view, but when you are the wastewater treatment operator or water utility manager or even consultant helping these people, with their day-to-day goals, they are a little bit different probably, right? They are very specific, like to take care about non-compliance with current effluent standards, for instance, for your specific wastewater treatment plant. Or with growing people coming into the city, the lack of capacity to handle organic load. It could be the cost issue, like there is a pressure from the local government or local even operators say, well, we need actually to sustain our operations also by reducing the cost for either chemicals or energy use. It could be the political pressure. So there are many of those, but these are very specific, right? And every treatment plant might have a different challenge, but they are very common. And So they could be handled in several groups of focus, speaking about how the treatment plant as the facility works in the way of technology, what does it cost, and whether it complies with the standards. And all of these three groups of targets or KPIs, if you like, are somehow interacting with each other. And then it makes a challenge a little bit more complex than usually. We like to address it, let's say today, with the help of modern technologies, with something that we call the twin plan, the digital twin of wastewater treatment plant. And digital twin is a word that is very outspoken these days. Everyone thinks that everything has to be digital. And I do not like to take advantage of the bad situation that the world is living today because of Corona-19, you know. Even now we see, let's say, the move to digital world just because we must do it, right? And the speed of how the people are learning to use the technologies, it's tremendous. So, I mean, for day-to-day lives, even those that are not thinking to use these kind of technologies, just to talk to your peer colleague because we are locked at home. We have been dealing with that kind of digitalization for some time. And speaking about wastewater treatment plant digital twin, we may address it that how it works. It actually that we like to optimize the performance through integration of physical and virtual system. That's digital twin. Digital twin is a representation of the physical system, and in real-time data-driven calculation. Before I go even farther down to the road of what the technology is behind that, let me address the little bit more general how we see what is a digital twin and what stages of this digital twin we may look for. Because digital twin is not the product. This is nothing, let's say, like off-shelf software that you buy and you just start to apply it. There is a process how you get into the full implementation of digital twin of your system. And when I say system, it could be, speaking water, it could be the operation of harbor, or it could be water distribution network. Here we are talking about one particular facility, and that's wastewater treatment plant. And many of the wastewater treatment plants are looking into this picture here, are in a stage number 1 or 2. Stage number 1 or 2 to describe and diagnose, let's say, the system means that there are sensors in the treatment plant inside, they are providing some data, there are SCADA systems or some control rooms installed that operators are looking into these data and saying whether this is deviating from the normal operations. And then by experience, they usually take some measures, either on the data itself or with a little bit of help of analytical tools. Only few or much less number of the treatment plants are now operating in the mode on the upper part of the picture. So there is a prediction of how the treatment plant is operating, or even in the mode that these digital tools can drive the operational of treatment plant by itself without too much of human interaction. And this is what I would like to discuss today, about how to move from the earlier stage of treatment plant to the later stage or the final stage of implementation. We call it road to wastewater treatment plant at its best, or road to twin plant, how we see it, with the several steps coming from the review and analysis through design optimization up to the real-time and operational control of the wastewater treatment plant. So let's go, let's say, to the first stage of the implementation of twin plant, and that's the review and analysis. And I will, let's say, go through it very quickly, because that's the stage where most of the treatment plants are already today, likely. And that's here. They are actually they do have the systems that describe about how the treatment plant works, and then someone is taking decisions about whether this is fine or not, or if not, what to do with it. And when I say someone, it's usually the very experienced person as a wastewater treatment operator or group of persons, and actually making these decisions by their experience. Still, when the utility or treatment plant operator or consultant like to actually go through the path through the stages to up to the prescription or automatic, let's say, run of treatment plan, we pretty much recommend to do something that we call review and analysis of these data. Just because we do not believe the assessment of the local people or something like that, but there is a good reason to believe that through the analysis of data coming from the treatment plan today, we may estimate a potential for improvements, like for cost savings on operations, or such as the plan modification. We usually do this ourselves, or we do it with a consultant who is somehow closer to the wastewater treatment operator. There are many of consultants listening today, and you guys are very close to your clients, whether for design of treatment plan or rehab projects or just implementation of some fast measures because of different flow patterns or something. So we usually call the consultants as a partner in here and say, well, we like together to make this idea catalog and also try to estimate the expected ROI, return of investment. So because the twin plan implementation, it's not like let's say thing for one day. So it has to be some good reason and evaluation whether these investments are coming back in some time. I will come to that later, let's say, with some of the examples. With this data here, we can use the systems that are established, let's say there at the treatment plants, or we somehow may offer our own tools. One of them is DIMS Core. This is the data integration and management tool or management system. And when I say integration, it means that it doesn't replace the already existing SCADAs and systems of reading the data and sending them out and storing in the database. That integrates the information management systems. It's doing the real-time monitoring and reporting if necessary, but it also can stay behind the existing systems and help the data assimilation when the sensors are, let's say, falling down and things like that. So it could be very useful for reading this production data, sensor data, operational status. Some treatment plants, they do have the assimilation, or not treatment plants, but water utilities. They use their own data assimilation tools for that kind of thing, for the data analysis. It's very quite common structure that it reads custom information system here, and some data, for instance, financial, and can produce the report for the management saying these parameters are doing well. So this is the described type of digital twin. Well, it is not a full digital twin, but it actually says something about it. But who is going to take the decision in here? Based on data, that's the operator, that's the human being, that's the guy looking into data and say, well, here it is red, and I need to do something. We as DHI today, we also offer a little bit more advanced kind of data analytical tools, and this is through our Mike Cloud service that we built our own Mike Cloud platform based on Microsoft Azure platform. And when I say we, I mean DHI. We run several of our tools at the cloud, on a native cloud, like Flood Screener, like Mesh Generator, like the other tools that all the water professionals are using around the world to know better where you are. So it's a quite like a native service through the cloud. And at this cloud platform, we also offer the data analytical tools with the quite nice features, as you can probably see, like web access to that, easy workflows. This uses Microsoft Azure cloud platform with all the benefits that it can offer. We do both. We do, let's say, the data analysis at the side of the treatment plant or inside of the water utility infrastructure on their own infrastructure. There are many water utilities around the world that sees their data about treatment plants as the sensitive information or even classified. And because of data and cybersecurity, they simply do not allow to spread these data, let's say, to some other facilities outside their firewalls. On contrary, there are countries where the water utility sees they're using the cloud services outside of their own infrastructure as very beneficial for them. So that's either or. We do not mind. Well, we do not mind the choice of the customer or consultant. We of course prefer to go the very modern way. So let's say using the cloud services as much as possible to extend what it offers. So that's actually very briefly about the data, how to provide, let's say, this catalog of possible measures based on the data that are available at the treatment plant today. And sometimes the decision could be taken at that level. So the next phase, we call it next phase, not the second, of the implementation here, implementation of the treatment plant. It's actually what we call design and optimization. And to well-known picture here, so we move from the stage number one, where we describe how it works by data and sometimes take decision on that level of information. We move into diagnosis of how the facility works. And in treatment plants, we are definitely talking about design and optimization, modeling of the treatment plant. When we say modeling, there are a number of the tools at the market. DHI also provides on our own product, West. That's the modeling and simulation package for wastewater treatment plants, not only treatment plants, I will come back to that later. And this analysis simulates the process of treatment plants. And in this stage of twin plant implementation, it serves mainly for offline scenario evaluation. And when I say scenario evaluation, it could be very different scenarios, like scenarios for upgrading of treatment plant, or some troubleshooting when some of the parts of the treatment plant or aerators stop working and what to do with this, or operational patterns. By the way, once again, speaking of situation that we are living, all of us today, the inflow patterns has changed quite drastically. At least there are already evidence in Europe and probably also in the other parts of the world, but I've seen actually some data from European water utilities just recently that the patterns of the flow and also load has changed drastically because people are working at home. So there are no peaks at 7, 8 o'clock in the morning before the schools. There are no peaks in the afternoon. It's almost flat. And the load for the treatment plants is also very different because of shutdown of industries and so forth. So this is actually why we should have something like a dynamic model of the facility or the treatment plant, if you like, to look at the different operational patterns and suggest what to do in the new conditions. How does it usually work? It works that consultant is actually making the model or using the model that exists, take some offline scenarios, and then provide a report, even online or offline report to the treatment operator and say, you should do this and you should do that. Sometimes it does by the treatment operators itself on rarely basis, but there is a certain actually offline support for decision making. As I said, one of the tools that you can use is the one of DHI, West, the modeling simulator for wastewater treatment plants. It actually includes dynamic simulator and model libraries for many other things, but also for wastewater treatment plants, because this is what we are talking today. Or you can use it like a generic tool for modeling. This is not a presentation of a product and will not be a presentation of a product. If you are interested about more details in these products, either DIMSCORE or West or any other product I'm going to mention, DHI runs the special product line of public webinars and presentation of our own products. But this is really not the webinar about selling the products for a specific purpose. So if you have some let's say questions about that, I will be happy to answer later on about it. So back to why I mentioned these libraries, because it looks something like that. And if you pull the model of the wastewater treatment plant out of the product together with all the relations, it can look like that. And that this is the layout that shows the complex of the network of control connection in the wastewater treatment plant. If you have a large treatment plant, it could look even much more complicated. That sounds really awful. However, the client doesn't see it, right? The operator sees something like this. So the dashboard that actually shows the different parts of wastewater treatment plant, whether it works fine, whether it works close to the limits, whether there should be some sort of action, what are the data behind that, and some easy tools about how to make these scenarios happening. So this offline model, and that's the second stage of implementation of treatment plan, of digital representation of treatment plan, is used very often for experimenting with different scenarios, testing them, but also for the staff training about what to do if this happens, what to do in reality, because they are well trained by digital representation of their treatment plan. That could be used also for the staff training in the stage of treatment plant rehabilitation or even construction. One of the examples is that we, together with our partners, did it for one of the biggest treatment plant in Central and Eastern Europe, that's Czech in Poland. That's the treatment plant of Warsaw, that has been built for close to 2.5 million person equivalent treatment. And it has been used exactly for the, not only during the plant construction kind of optimization, but also for training of the future operators on the data about how to run the treatment plant for different scenarios and use as a complex control rules for that large treatment plant. Another example could be how it's integrated into existing treatment plant. This is the example from Italy, where we join our forces with one of our partners, ETC Sustainable Solution. That's the company in Italy who actually provides the system for wastewater treatment plant control and operation. They call it OSCAR. And these OSCAR, systems were based on the like a dashboard for description how the system, how the treatment plant works. And we put the WEST model behind the screen and behind the scene with the online optimization scenarios and improve that performance index comparison by biological treatment modeling cases, and enable some achievements like improve nitrogen removal and energy savings and so forth. So this is an example how these, on a first look, very complex models can be, let's say, a little bit hidden to the operators and can still benefit, offer the benefit, let's say, to them in proper way. And then the final phase of implementation of the twin plan is, of course, not of course, but it is online forecast and real-time control of the facility. And I will again come back to the well-known sketch of the digital twin compared to the physical system. So we are moving to this stage where the tools that we can use are used not only to diagnose about what could happen in certain circumstances, but what will happen. So it means that we move from diagnosis part to the prediction part. What is going to be the performance in the next hour, in the next 6 hours, in the next day, based on the forecast of the inflow, based on the forecast of the load. And if we move farther up the road to the prescription, let's say, type of implementation, we even allow these digital systems to drive the performance of the treatment plan. And when I say to drive, it means that we will allow the digital representation to change set points, to set up the new triggers for aeration, for instance, and run the treatment plant automatically. So we allow the automation of the processes based on the deep insight knowledge that we are getting about the processes inside the treatment plant. So how does it work? Data from sensors, and this is the first stage, right? Data from sensors are collected through some tools, DIMS, MyCloud, whatever externals, let's say, tools, and they are used to calibrate the model, for instance, the Western here, and then running the model of the treatment plant. The model provides virtual sensors back to some data storage. And these actual data coming from the treatment plants, together with the virtual data, are published online through, for instance, the dashboards. And model runs are used for optimization decisions. And here is a dashboard suggesting about what is, or displaying, not suggesting, displaying what is going to be the performance of that facility, in this case, wastewater treatment plant, in next hour, 6 hours, day, or something like that. So what is the difference between this and the previous stages that I was actually speaking about? The difference is only one word, that this is happening in real time. So all of these all of these tools has to be ready to do all the tricks and all the performance in real time. So the data assimilation tool should be okay to run it through the firewalls or through the cloud applications in real time very fast. The model should be ready to run in a seconds or a minutes very fast. And all the system has to be configured in a way that it can be used in real time. So we move the uncertainty about what could be the next performance or next setup of the treatment plant into the what will be the next performance. And then we can, or the operator can react accordingly. Background works like this. So there is a wastewater treatment plant on the right side. The current state is pushed through some data acquisition or assimilation tools into either the virtual plant simulation that is updating the state of the treatment plant and let's say the set point optimization, which are two different kind of let's say model runs. One is keeping the model up to date. We can call it also auto calibration, and the one is actually running the set optimization based on the objective functions that we would like to optimize, because we can optimize against the cost of the chemicals. We can optimize some objective functions as aeration energy or anything like that. One of the objective functions advantage could be actually something like that. So the minimum advantage outside of aeration energy. So, sorry for that. There were some people coming here, let's say, in the room. So let's say this, one of the objective functions could be like that. And you can run, let's say, in our test case, the standard 2-tank nitrification system, and you run 1 day of simulation at time and get results about these set points. In a little bit more, let's say, more sophisticated way, let's say, how does it work? Once again, there is a treatment plant, provides the state to the data manager store, and then there's a run of the model, for instance, weekly, that provides the model parameters, so it actually calibrates the model according to functions, and then there is optimization run, for instance, hourly or daily, that provides the set points in here back to the treatment plants. Here, we do have an options. The model parameters and set points are actually just displayed, and there is a human being making decisions. We adopt the strategy or not, or we can move to the next stage to make automation of that kind of the state. This left side model data combination can be also used to run the simulation as kind of testing scenario and things like that. In reality, it looks like that. So there is a hardware and quite complicated kind of setup. Once again, for user, it's quite simple. This is integration as an example with Siemens PCS7 SCADA, quite well-known kind of system, let's say, for many treatment plants around the world. So the user and treatment operator can work in the environment that this is known to him or her as a treatment operator person, and the DIMS and West integrates inside of the SCADA system with the triggers and pulling up the set points into the SCADAs with the options saying do it, not do it, or do fully automation kind of control of the treatment plant. The another example could be the decision support system that we have developed for one of our clients in China, where there was a request for completely custom-based user interface for controlling of a treatment plant. So on the background that I've just shown you 2 slides ago, we built the customer base user interface with a specific treatment plan. Here you can see it on a picture with a specific data to be shown and triggers with a real-time warning module that it's going to be online to mobile devices if something is happening, so that people outside of treatment can be notified for real-time, let's say, situation. And these kind of system can, cut decision time from very many hours to the minutes, being online from different places, and optimize the strategy to achieve energy savings. So this is another example. What I would like to demonstrate here is that the user interface is very configurable in a way that it could be done on demand, or it could be, the system could be integrated into well-known SCADA systems, or being on Microsoft Azure platform, or Mike cloud platform, because we develop our own platform based on Microsoft Azure. Some simple dashboarding tools can be used as well, which are integrated with Microsoft Azure products like Power BI, for instance. I would guess that many of you would have a chance to work with Power BI in Windows Cloud, and that could be also used, let's say, for displaying the performance of the treatment plan based on these data and modeling background here. So that's the final stage, right? That's the final stage, that these data tools and the models are integrated together and run in real time to provide the information what is going to happen in the treatment plant in the next period, an hour is 6 hours a day, and then allow the treatment operators to take the decisions, qualified decisions, about how to optimize the run. The optimization modules could be also integrated in that, so but this is a little bit beyond of that technical, let's say, scoping here in the end. So if you like to have some questions about it, I will come back to that later. So this is how, let's say, the twin plant is implemented in the final stage. When we talk about wastewater treatment plant digital twin, I was talking almost like 45 minutes about data and models and decisions. But implementing this is not only the technical part, that's also the human interaction in between the systems and the user. So when we implement the twin plant together with the consultant to the customer, or directly for the customer, treatment plant operator or water utility, the co-creation with the customers is the key for us, because it could be, well, the easiest example is that the customer should actually say how the interface should look like. Okay, whether this is completely built on the case like I've shown from China, or whether it's fine to use the Power BI dashboards that they can configure by themselves. So this is very inevitable part of the building of the system, because this is what the operator interacts with. But it's not only about that kind of example. It's about engagement and creation of the value through this digital journey, about where we see the most important value of the digital twin. Is it the operational cost? Is it the reporting for the authorities? Is it compliance, or make sure that the twin plan, the treatment plan is working stable? So that's very important, let's say, part of implementation. Co-creation and engagement of the final user. By this co-creation and engagement, we also provide a knowledge transfer, because we are at the same boat, right? And we are actually doing it somehow together. And this is what we call the DHI road to the intelligent and smart wastewater treatment plants. This is how we get twin plant, your plant, and its best. Thank you very much for listening. Have a good day.